So this video is on tangents and normals, and then we'll get on to increasing and decreasing functions later in the video. So you may be asked to find the equation of a tangent. Now a tangent is a straight line. If you go back to chapter 5, you can't recall how to find the equation of a straight line. The equation of a straight line is y minus y1 is equal to m and then x minus x1. So in order to find the equation of a straight line, you need a coordinate, any coordinate on the line, so x1, y1, and then you also need the gradient of the straight line, of the line, so m. So if we know the point in which the tangent touches the curve, then we're able to find a coordinate on the tangent, because obviously that will lie on the tangent, the point where the tangent touched the curve. And if we know the x coordinate of the point where the tangent touched the curve, and we know the function of the graph of the curve, then you can differentiate f of x in order to get f dash of x, the derivative, and then using that x coordinate you can then find what the gradient is at that point of the curve. And then remember that tangents and the point in which it touches the curve, they have the same gradient, and you can use this in order to find the equation of a tangent at a specific point. So here's an example of a question you could be asked where we have a curve 6x cubed plus 5x minus 1, and we're told there's a tangent at x is equal to 2, and we need to find the equation of the tangent. So just to be clear of what's going on, you don't necessarily need a diagram for this question. Just to be clear, we have a section of the curve and we have a tangent at one of the points, and we know that the x coordinate of where it touches is equal to 2, and we need to find the equation of this tangent. So we need the gradient and we need a coordinate on the tangent. Well, we can find the gradient because we know the x coordinate and we know the equation of the curve. So therefore we can figure out the gradient of the point on the curve and therefore the gradient of the tangent, because we can differentiate this. So f dash of x is equal to, and then we're going to differentiate this term by term. So 6x cubed is going to be 6 times then x cubed is 3x squared, which is 18 x squared, and then 5x differentiated is 5 because just the x just goes away, and then the minus 1 goes away. So f dash of x is going to be 18 x squared plus 5, and therefore we just sub in 2 to find the gradient at that point, the gradient of the tangent. F dash 2 is equal to 18 2 squared plus 5, which if you put into a calculator is equal to 77. So the gradient of the tangent is equal to 77. Now I talked about this in the first differentiation video. There's a really good way for you to check whether this is the right answer by using the d over dx function in your calculator. If you put in this function and then you put the x equals 2 part, the x equals part as x is equal to 2, it also gives out a value of 77. So this is a really good way to check if you've got the right answer. If you don't know what I'm talking about, go back to the first differentiation video where I talked about it. It's a really useful thing to know. And now we need to find a point. We know the x coordinate of this point, but we don't know the y coordinate. However, we can easily figure this out because we know the equation of the curve. So therefore, because it lies on the curve, therefore f, and it's 2, is equal to 6 2 cubed plus 5 2 minus 1, and if you put that into a calculator, that is equal to 57. So therefore the coordinate is 257, and now we can find the equation of the tangent because we have a point and we have the gradient. We can use the equation y minus y1 is equal to m x minus x1, so it's going to be y minus and then 57 is equal to m, which is 77, then x minus 2. This is all in the chapter 5 videos of the kind of specifics of this, of the equation of a straight line. Expand the brackets to y minus 57 is equal to 77x minus 154. And I'm just going to move this onto the other side to do 77x minus y, and then it's going to be minus 97 if you put into a calculator, is equal to 0. And this is the equation of the tangent. So they might also ask you to find the equation of a normal. So this might not be a term that you've heard of before. So here is a graph and we have a tangent on the graph. So a normal is a straight line that's 90 degrees to the tangent and passes through the same point. So what it is a line that passes through the same line that the tangent touches the curve through here, and it's 90 degrees to the tangent here. So remember that the equation of a straight line is y minus y1 is equal to m x minus x1. So we need a gradient and then a coordinate in order to find the equation of the line. Well, we know the coordinate because it's the same point that the tangent, that we use for the tangent, it's the same point. And m is going to be the negative reciprocal of the gradient of the tangent because they're 90 degrees to each other. Go back to the, again, chapter 5, the perpendicular and parallel lines section. But basically the negative reciprocal is minus 1 over m of what the tangent is, so that is what the gradient of the normal will be if we find the gradient of the tangent. And we talked about earlier how we can find the gradient of the tangent quite easily, so therefore we just use this in order to find the gradient of the normal, and we can find the equation of the normal. So here's an example of a question they could ask where they give you the equation of a curve and they give you a point through which the normal goes through and which is attached to the curve, and they want you to find the equation of the normal. So we know the point, we just need to find the gradient, and this complementary tangent here, we can find the gradient of this easily as we know the x coordinate for which it goes through. So we can just differentiate this. So it's going to be dy over dx is equal to, and then we differentiate the terms individually, so it's going to be x squared is 2x, then minus 5x is minus 5, and the constant just goes away. So dy over dx is equal to 2x minus 5, and then we just sub in 1 as the value, so it's going to be 2, 1 minus 5, which is equal to minus 3. And again, you can use the calculator using the d over dx thing by putting this in, and then putting x equal to 1 in, and it also gives out the value of minus 3 to check. And now we have a point. Now the gradient, this is the gradient of the tangent, minus 3, and we need to find the gradient of the normal, so it's going to be the negative reciprocal, so the gradient is going to be, the negative is going to go away, so it's going to be 1 over 3. So now we have a point and we have a gradient, so therefore we can use the equation y minus y1 is equal to m x minus x1 y, and then it's minus 10, so it's going to be minus minus 10, so it's going to be plus 10, is equal to 1 over 3 x minus 1. Expand the brackets to y plus 10 is equal to 1 over 3x minus 1 over 3. And then bring this onto the other side to do 1 over 3x minus y, and then it's going to be minus 31 over 3 is equal to 0. And then we like this for the equation of a straight line to be an integer, so times everything by 3 to get x minus 3y minus 31 is equal to 0. And that's the final answer. So finally, I want to talk about increasing and decreasing functions. So a graph is increasing when it is going up, so it has a positive gradient, and most importantly, dy over dx is bigger than or equal to 0. And then a graph is decreasing if the graph is going down, has a negative gradient, and again, most importantly, if dy over dx is less than or equal to 0. So a graph can either be constantly increasing or constantly decreasing. For example, with this cubic, for every single part of this cubic, the gradient is always positive. The graph is always going up, except for this part here where it's 0, but this is increasing. The gradient is always positive. And therefore, in this graph, dy over dx is always bigger than or equal to 0, so therefore in general this cubic is an increasing function because it is always increasing. Dy over dx is always bigger than 0. But for other graphs, it can have sections where it's increasing and sections where it's decreasing. So for example, for this section here, the gradient is going down until about here. So for this part, the graph is decreasing. And then here, it's going up to about here where it levels off. And for this part, it's increasing. And then up to here, it's decreasing again. It's got a negative gradient until about here. and then after this it is going up again all the time, so it is increasing. So for this particular function, it's decreasing in certain areas and increasing for other sets of x. So they may ask you to prove that a particular graph is always decreasing or always increasing, and you can do this using completing the square. We discussed this in completing the square vids in chapter 2, and this is a really useful method in general to remember for if you need to prove if something is always positive or always negative. But go back to those videos if you need a reminder of how this works. So to prove this graph is always increasing, therefore we need to prove that dy over dx is always bigger than or equal to 0. So the first thing I'm going to do is find dy over dx. So dy over dx is going to be equal to, and we differentiate each term individually, so x cubed is 3x squared, minus 9x squared is minus 9 times 2x, which is equal to minus 18. X, 30x is going to be 30. And then the plus 1 just goes away. So therefore dy over dx is 3x squared minus 18x plus 30. And again, you can check this using your calculator by using this in the d over dx function, putting in a random value of x and then subbing that random value of x into here in order to see that you get out the same value. Okay, now we're going to use the completing the square thing. So what we're going to do, please go back to the completing the square vid in chapter 2, because I'm not going to go through the whole kind of how it works and stuff like that. Firstly, what we need to do is factorize out this 3 from the two first terms. So it's going to be 3x squared minus 6x plus 30. And then we're going to half this coefficient and get rid of this square so we can put the square on the outside of the bracket. So it's going to become 3x minus 3 squared, but we need to account from the number that's going to be produced here, which is going to be minus 3 times minus 3, which is 9. So we need to minus 9. That's plus 30 on the end. Please remember to include the minus 9 in this bracket with the 3, because that will also be affected by the 3. Let's expand the brackets to get the minus 9 out. So it's going to be 3 of x minus 3 squared, and then minus 9 times 3 is minus 27. Like this, and then we can simplify it. 3 of x minus 3 squared, and there's going to be plus 3. So we know that x minus 3 squared is always going to be bigger than or equal to 0 because it's a square number. So therefore 3 of x minus 3 squared is also going to always be bigger than or equal to 0. So therefore 3 of x minus 3 squared plus 3 is always going to be bigger than or equal to, it's always going to be bigger than or equal to 0. It's also always going to be bigger than or equal to 3. So therefore dy over dx is always going to be bigger than or equal to 0 as required. And again, if you don't understand what's happened here, go back to that completing the square vid in chapter 2. They could also ask you to prove that a graph is always decreasing. It's the exact same method, but you just use the minuses and do it in the opposite way instead. So it's always decreasing, and that means that f dash of x is always going to be less than or equal to 0. So first of all, let's find f dash of x. So f dash of x is going to be equal to, and we differentiate each term individually. This term is going to be minus 1 over 3, and then it's going to be times 3x squared, which is equal to minus x squared. This term is just going to be 2x, and then this is just going to be minus 2. So therefore f dash of x is equal to minus x squared plus 2x minus 2. And we need to prove this is always less than or equal to 0. So the way we can do this is first of all factorize out this minus 1. So it's going to be minus, so remember it is minus 1, we don't actually write it, of x squared, and it's going to be minus 2x, and then minus 2, we don't include the minus 2 at the end, and then we do the trick where we half this, so it's going to be x minus 1 squared, and then 1's going to be produced here, so we need to minus 1, again include this in this bracket here, minus 2, expand the brackets to get out the minus 1, so it's going to be minus x minus 1 squared plus 1 minus 2, and simplify to get minus of x minus 1 squared minus 1. and we need to prove that this is always less than or equal to 0. So x minus 1 squared is always bigger than or equal to 0. It's a square number, so that means minus of x minus 1 squared is always going to be less than or equal to 0. So therefore, minus x minus 1 squared minus 1 is always going to be less than or equal to minus 1. So therefore, f dash of x is equal to is less than or equal to 0. So we've proved it, so that's the final answer. So if we have a situation with the quartic at the start where we have it increasing and decreasing in different sections, for a cubic where it differentiates into quadratic, they could ask you to define where it's increasing and where it's decreasing. So to do this, we find the quadratic derivative, and then depending on if we need to find it decreasing or increasing, we make a quadratic inequality, and we learn how to solve quadratic inequalities in chapter 3 in the quadratic inequalities video. So here's an example of this where we have this curve here, and we need to find the interval where this is a decreasing function. So remember, decreasing is when dy over dx is less than or equal to 0. So first of all, let's find dy over dx. So dy over dx is equal to, and then we differentiate each term individually. So x cubed is going to be 3x squared. 3x squared is going to be minus 3 times 2x, which is equal to minus 6x, and then minus 45x is going to be minus 45 as the x just goes away, and then the constant just goes away as well. So dy over dx is equal to 3x squared minus 6x minus 45. And again, you can check this in your calculator by putting this function into the d over dx thing and then doing any value of x and then subbing that into here to see if you get the same value. Okay, so we need to find the interval where it's a decreasing function, so this is where it is less than or equal to 0. So when this is less than or equal to 0, and now we have a quadratic inequality which we can solve. Now I'm not going to go through a complete tutorial of how to do a quadratic inequality. That is in the chapter 3 section in the quadratic inequalities video. I'll just go through it very quick, but go back to those videos if you need a refresher. So we first of all make an equal sign, so 3x squared minus 6x minus 45 is equal to 0. I'm going to divide everything by 3 quickly. Minus 2x minus 15 to make it a bit easier to solve, though you could use your calculator in order to solve the quadratic, and then we just solve it. I'm just going to factorize it quick, so it's going to be x here and then x here is equal to 0, and it's going to be minus 5 and plus 3, so therefore x is equal to 5 and minus 3. Therefore, we draw a quick graph, really rough. So this is y, and this is x. And we know the roots are 5 and minus 3. So again, just a really rough graph, kind of like that, where this is minus 3 and this is 5. And we need to find where this graph is less than or equal to 0. So this is going to be this section here. This is when it is less than or equal to 0, because this is when it is below the x-axis. So therefore, because we know these roots, therefore this area is going to be when it's bigger than or equal to minus 3, because remember it can be equal to 0 as well, and 0 is where it's minus 3 is where it's 0, so it could be minus 3 as well, x, or when it's less than or again equal to 5. And that's the final answer. Again, go back to the quadratic inequalities video if you need a bit more of a refresher of how quadratic inequalities works, and please remember the equals signs here as well, because you will lose a mark if you forget that, because for a decreasing function it could equal to 0 as well. Okay, so here's a couple of questions on tangents, normals, and then increasing and decreasing functions. So pause the video, have a go, and I'll go through the answers in about 5 seconds. Okay, so for part A, I've drawn an axis. I'll most likely give you, or they'll definitely give you an axis in the exam. So this is chapter 4 content, so go back to that if you can't remember. So we need to find whether it's a positive or negative graph, its roots, and the y-intercept. Well, it's going to be a positive graph because if you multiplied out everything, you can see that it would be a positive coefficient on the x. Remember that this squared means that there's 2x plus 3 brackets, so it's going to be a positive graph. And now we need to know its roots, which we can do very easily by saying that it's equal to 0, so it would be x plus 1 and then x plus 3 squared is equal to 0. So therefore the roots would just be x is equal to -1 and -3, where this will be a repeated root. So therefore the roots are -1 and -3, where this is going to be a repeated root. And then the y-intercept is just going to be what happens when you expand the whole thing and what's going to be the very last term, which you can figure out by timesing all of the last numbers together. So it's going to be 1 times 3, but remember there's a square here, so it's actually it's actually x, another x plus 3 here if you were going to expand it out. So therefore it's going to be times 3 again, which is equal to 9. So therefore the y-intercept is equal to 9. And then we could just sketch it. Okay, so it's going to be a positive graph, so the roots are going to be at -1 and -3. So I'll say -3 is about here, I'll say -1 is about here, and we have a y-intercept at 9, and we'll just say that's about here. Remember that the y and the x axes are not relative to each other, so even though this isn't really at 9, it doesn't really matter too much. And then we just sketch a positive graph that goes through these coordinates, remembering that this -3 is a repeated root, so it's going to look like this, where it comes up, touches this here, and then goes back up like that to that root, and then goes up like that. And we need to show the coordinates of the points where C meets the x-axis. So this is -3, this is -1, and this is 9. Therefore, that's the curve. So that's the final answer. So for part B, we're going to need to expand this whole thing here. So it's y is equal to x plus 1, x plus 3, and the square here means there's another x plus 3 bracket, like that. I'm going to start by expanding these brackets, so it's going to be equal to x plus 1, and then it's going to be x squared, and then if you expand the whole thing, it'll be plus 3x, which is equal to plus 6x, and then plus 9. And then we times these two brackets together. So x times x squared is going to be x cubed, x times 6x is going to be 6x squared, then x times 9 is going to be 9x, 1 times x squared is going to be x squared, 1 times 6x is going to be 6x, and then 1 times 9 is going to be 9. And then we can simplify this by doing x cubed, and then we've got 6x squared and x squared, so it's going to be plus 7x squared, and then plus 9x plus 6x, which is going to be plus 15x, and then plus 9. So that's what y is equal to, and now we can differentiate this. So dy over dx is going to be equal to, and then remember we differentiate each of these terms individually. So x cubed is going to be 3x squared, 7x squared is going to be 7 times, and then x squared differentiated is 2x, which is going to be equal to 14x. 15x is just going to be 15, and then remember that when you differentiate a constant, it just goes away. So therefore dy over dx is going to be 3x squared plus 14x plus 15, which is what's required. Okay, so for part C, we're told we have a point A and we have the x coordinate -5, and we need to find the equation of the tangent at that point A. So what is basically happening is we have a section of the curve, and then we have a tangent at a point where the x coordinate is equal to -5, and we need to find the gradient of the tangent. Okay, so to find the gradient of a straight line, to find the equation of a straight line, sorry, we need to know two things. We need to know the gradient, and we need to know one coordinate on the line. We can find the gradient because we know dy over dx, and we also know the x coordinate. So therefore, if we just sub in -5 into here, we find the gradient of the point on that curve, which will also be the gradient of the tangent. So sub -5 into here, so it's going to be 3 of -5 squared plus 14 -5 plus 15, which you can put into a calculator, is equal to 20. So therefore the gradient is equal to 20. So we've got the gradient, and therefore we need to find a coordinate, which you can also easily do as well, because we know the x-coordinate, and we can figure out the y-coordinate easily by just subbing into this equation for the curve. So just sub in -5, so it's going to be -5 plus 1, and then -5 plus 3 squared, which if you put into a calculator is equal to -16. So y is equal to -16. So therefore the coordinate is -5 -16. So now we can figure out the equation of the straight line by using the formula y minus y1 is equal to m of x minus x1, and then we just sub in the values. So it's going to be y minus, and then y1 is -16, so it's minus -16, so it's going to be plus 16. It's equal to m, which is 20, x minus -5, which is going to be plus 5. Expand the brackets to get y plus 16 is equal to 20x plus 100, and it specifically says that it wants it in the form y is equal to mx plus c. So move the 16 onto the other side to get y is equal to 20x plus 84, and that's the final answer. So for part D, we're told that we have another point B that lies on the curve, and that the tangent to the curve at A, which is the point that we did before, and this new point are parallel. So if the two tangents are parallel, that means that they have the same gradient. So that means the tangent of this new tangent at this new point is also going to be equal to 20, which was the gradient of the tangent before. So what can we do with this now? So we know that this is going to be the gradient of the tangent, and we know that dy over dx is equal to this. Remember that this gives out the gradient, and we know the gradient of this tangent. So what we can do is equal this to this gradient. So it's going to be 3x squared plus 14x plus 15 is equal to 20. So this is the gradient, and we know that this point is going to have this gradient at this point on the curve, and we have a quadratic equation, and we are hoping now that if we solve this quadratic equation it will give out two values, one where x is equal to -5 like the equation of the tangent for the last one, as we know that this is the gradient of this tangent, and the other x coordinate should be the x coordinate of b at this new tangent. So if we solve this, it's going to be, let's make it equal to 0, so 3x squared plus 14x, and then it's going to be -5 is equal to 0. We have a quadratic equation that we can solve, and I'm going to be do it by putting it into the calculator. If you don't know how to do that, go back to the solving quadratic equations in chapter 2, part 1, the very first video in that set of videos. And if you do that, x is equal to -5, which is a good sign because we know x is equal to -5 because we know that that is the gradient of this tangent, and the other coordinate is 1/3. So therefore we know that this has to be this point here. We know that x has to be 1/3 for this point because we know that the gradients are parallel, the tangents are parallel, sorry, so the gradients are the same. So this is the other x coordinate, and this is the final answer. So for question 2, we're given this curve here, and we need to find the set of values for where this is an increasing function. So remember, an increasing function is where dy over dx is bigger than or equal to 0. So first of all, let's find dy over dx, and this is going to be equal to, and then we just differentiate the terms individually. So 2x cubed is going to be 2 times and then 3x squared, which is equal to 6x squared. And then it's going to be -3 times an x squared differentiated is 2x, so it's going to be -6x. -12x is going to be -12, and then the constant just goes away. So therefore dy over dx is equal to 6x squared minus 6x minus 12. And again, you can check this answer if you want to by putting this function into your calculator and then putting in a random value equal to x and then subbing in that value for x to see if you get the same answer. And we need to find the set of values for when this is bigger than or equal to 0. And this is quadratic inequality, and we learned how to solve this in chapter 3. So the first thing we do is equal this to 0, so 6x squared minus 6x minus 12 is equal to 0. I'm going to divide it by 6 to make it a bit more easier. X squared minus x minus 2 is equal to 0, and then we can factorize this to x minus 2, x plus 1 is equal to 0, so therefore x is equal to 2 and minus 1. And then we can draw a quick graph. Well, this is y, and this is x, and it's just going to very broadly look like this, where this is -1 and this is 2. And we need to find the set of values for where this is bigger than or equal to 0. And this is going to be here when it's on top of the x-axis, and here, but remember it can also be equal to 0, so it can also be equal to these values. So therefore, dy over dx is bigger than or equal to 0 when x is less than or equal to -1, or when x is bigger than or equal to 2. Please remember the equals, because it can be equal to 0 as well, so it can be equal to -1 and 2 as well. And it wants to answer in set notation, and this is just going to be, so open bracket, this bracket here, this is x when x is less than or equal to -1, close bracket, and then this u symbol to denote or, x when x is bigger than or equal to 2, and then close bracket, and that's the final answer.